Hello and welcome back. So let us try to convert this problem, fives and not fives problem, into a binary class classification problem. To do that, the target variable should be either 0 or 1. So I actually took the digit y train, the y variable, which is a series object, and then used apply method. Inside it I used a lambda function. And when I say lambda function, it takes x. That means the first record it takes, maybe it is not 5. If x is equal to 5, it actually returns 1. If not, it returns 0. That's how the lambda function works. The number before if condition is going to be returned when it is true. If not, the number after else will be returned. So on apply, if I say it is going to, for each number it is going to return that, and I am overwriting that not 5 and 5 strings to 0 and 1. Okay, wherever it is not 5, it is going to put 0. Wherever it is 5, it's going to put 1. You play with this a little bit, you will understand what is that lambda function and apply function. Right? So I converted the problem into binary class classification problem. Now if you look at the y variable, right, the y variable digit y train, you will find only two unique values, 0 or 1. Okay. So now I am going to apply min-max scalar because I am going to use SGD classifier. I hope you remember we have used SGD regressor, stochastic gradient descent regressor. Here we are using stochastic gradient descent classifier. The algorithm behind the scenes working is logistic regression. For classification problems, logistic regression works. For regression problems, we have used linear regression and polynomial regression, whatnot. But for classification, logistic regression algorithm works, and many other algorithms are there. We'll discuss them in further classes. But here, the SGD classifier actually is implemented on logistic regression. So how gradient descent works on logistic regression, we'll see that also in coming classes. To make the gradient descent algorithm work, the data should be scaled, or in other words, the gradient descent algorithm expects data in scaled fashion, or all the columns should be on similar scale. Right? What is scale? The minimum and maximum should not be, too different for all the columns. So if you apply standard scaling or min-max scaling, the data comes into a certain scale, certain range. Okay. So we are doing min-max scaling and converting our data, or each column we are trying to bring it to similar scale. So to do that, in scikit-learn we have got min-max scalar, a class, and I created an object of it, and then I did fit transform. When I do fit on the data set, for each column it will collect the minimum value and the maximum value, and from each value it is going to subtract the minimum and divide by maximum minus minimum. So that's what it's going to do. So when you do fit, it is going to find the minimum and maximum values, and when you say transform, it is going to subtract from each cell value, it is going to subtract the minimum and divide by maximum minus minimum. For each column it is going to do. So for the column 1, pixel 1 column, it will find minimum maximum, subtract from each value, divide by maximum minus minimum. For the second column, it will take minimum maximum and again do the same thing. Subtract from each cell, divide by maximum and maximum minus minimum. Like that, for 784 columns, it's going to find minimum and maximum values and then apply it onto the dataset. Transform is going to apply it onto the dataset. Fit is going to find the minimum and maximum values. I hope you remember, anytime you build a model, you will do fit transform on train set and only transform on test set. We'll see that here also. The process will not change. Algorithms change, metrics change for classification. That's it. So I am applying the min-max scalar. So data got transformed. Now all the columns will be on similar scale. When all the columns are on similar scale, gradient descent algorithm works well. The SGD classifier is based out of gradient descent algorithm on logistic regression. So when I created a class of SGD regressor classifier, right, and I did fit, right? Fit of x and y, it will actually understand the pattern or it will derive the equation. What is the equation? The hypothesis function. We'll see that in coming class. So it understood. It actually created a class. It actually, the SGD classifier algorithm became a model when we passed the input and output. Now we can actually calculate accuracy. To calculate accuracy, there is a method called accuracy score. To accuracy score, we need to pass the actual y values and the predicted y values. To predict, what I did, I took the model dot predict and I passed all the x values. So I got the predicted values and the actual values, and I am calculating accuracy score and printing it here. So let us see how much we got. We have got 97% accuracy. That seems like the model is working good. Let us try to see how is it working on test set. So before we apply it onto test set, we need to apply two transformations. One, converting y variable into 0 or 1, because still on the test set we have got 5 or not 5. The strings are there. So we need to convert them into 0 and 1. That is one transformation. And the second transformation is need to bring all columns into similar scale. We already used min-max scalar here and we did fit and transform. So no need to fit again, because on train set we have got 80% of the data and the minimum and maximum values are going to be more reasonable. On a huge volume of data, the statistics will be more reasonable than the less number of data. On test set we have got only 20% data. So you should never be doing fit on test set. Whatever understanding we have got here should be used on test set and production both. So when you do transform, the minimum maximum values of each column which are saved into this min-max scalar when you did fit are going to be used and applied onto the test set. When you apply it onto the test set also becomes similar scale. All the columns come to similar scale. Now it is eligible to make predictions. So I did prediction here. SGD classifier.predict of x test, and I passed y test. Accuracy score I calculated. I have got 97.1% accuracy. It looks like good, right? It looks like model is working. As we have got 97.5% on train set and 97.1% on test set, it looks like working good. Why I am saying it looks like working good is the data set is imbalanced. I said the records belonging to 5 are 3700 odd, and the records belonging to not 5 are 38,000. That means only 10% of the data belong to one class and 90% of the data belongs to another class. It is called as imbalanced dataset. On an imbalanced dataset, accuracy measure will not work properly, or the metric accuracy will not give you proper assessment on whether the model is working good or not. It looks like model is working, but I am saying that accuracy is not a good metric for this particular dataset because the dataset is imbalanced. So we will see more clearly on what is imbalanced dataset, why accuracy measure will not work. If accuracy measure will not work, where to go. We have confusion matrix, precision, recall, F1 score, and we'll see how they work and how they actually give you an assessment on how the model is working. Let's meet in another session. Thank you.